Welcome to a new test and teardown video. This time it's a Thandar TF200 LCD frequency meter. And that one goes from 10 Hz to 200 megahertz. At least that's the official frequency range. It is in a little bit sad condition, as you can see here. It was just disassembled and put in a few bags together with the screws and some broken plastic parts and stuff, and the battery plate there. And also I got the manual. Instruction manual is quite impressive for a frequency counter. You shouldn't really need a whole lot of information how to use this, but it says a lot about frequency ranges and all that kind of stuff. It's a 3 ppm internal oscillator. And it also says something about socket A and socket B. So socket A is 10 Hz to 20 megahertz. And then socket B is from 15 megahertz all the way to 200. That's what I think is the most interesting stuff to figure out. Of course, they explain everything about the different ranges and how it works and yada yada. Not that super interesting. The funny thing is that half of the manual is the English version, and then there is a short version in French, German, and Spanish. Ah, that is so funny. And of course, if you don't know Thandar, it's of course a Sinclair company. Sinclair is also the guy that made the ZX Spectrum and ZX81 and all that kind of stuff. And Sinclair was definitely a super genius of the 80s. And yes, this unit is from 1980. And there's another little thing before we open it. This one here was calibrated in 1980. So it's probably even older than that. I'm quite happy that my model here is nice and wide. I did spend a little bit of time to clean up the front here, so it's really nice and beautiful. And it's also broken the other side. So we should definitely yeah, exactly. Well, this one is supposed to be broken, so I don't expect a whole lot of things to happen here. I can see we got a lot of corrosion. I kind of like the way that the LCD display here is implemented. There's a little LCD driver chip behind the glass, and then only these digits. So that's of course a multiplexed input system from all the counter chips. And that will be the slow and the fast input. Yeah, I don't really see anything that's blown up or anything. Yeah, there is a thing that worries me a little bit, and that is the input. I think, yeah, the center pin goes to a black wire. And the black wire is usually ground, but I will have to measure a little bit around here. At least I have wires for the battery holder here, so I could probably figure that out. What is what here? There'll probably be a little diode or a little transistor or something. Oh yeah, time base. So we got the internal time base. There's a crystal oscillator somewhere right here. Yes, here's the crystal. See, there's the crystal and the oscillator parts. There's the trimmer capacitor here for that oscillator. And then there's a buffer, obviously. And then you can select if you want the internal oscillator or an internal or external on that connector. So that is a great way to do it. Auxiliary power out, really? Well. This circuit board design, oh, you're gonna love this. The circuit board design, the tracks, VS, even the colors of the solder mask, that reminds me exactly of my old ZX Spectrum when I was a kid. That is so fantastic. Obviously it comes from the same designer and the same factory and all that. So that is just great. So the first few minutes when I powered this on, I had some just random funky digits all over the place. But now I just got some missing digits, but it's actually showing the right kind of thing. This is 200 megahertz input, and I am on the fast B input. And as you can see, yeah, we got a lot of stuff that is not working. If I go to 1 second, you see it's still 200 megahertz. And yeah, I think, yeah, see here we got some dots missing. So it's a display kind of thing that is causing all the problems. It goes to 220. Oh, what is going on? That is 200. Yeah, here we go. That is 200 megahertz, 210, and 220. So that is the input we got. Now I'll put it back to 200. I can go back to 10 megahertz and see it also works in 10 megahertz here. And then I can switch the input, and then we get 10 megahertz here. And so I think, yeah, basically everything works, but it's a display kind of problem. And that is not going to be super easy to fix, because the connection to glass here, that is these kind of snap into the glass kind of connections. And they probably added some varnish and stuff like that. I also see some really, really nasty, look here in the middle of the picture. See the white corrosion, absolutely gross, nasty stuff down there. So I believe we have to pull the entire display stuff here apart and see if we can just clean it real good, basically. At least that is my plan number one, and see if that has any positive effect. I don't know about the battery boxes. I really, really hate products with built-in battery boxes, but that is just me. I think it's because I've seen so many dissolved, puked batteries destroying entire the circuits and all that kind of stuff. So you need to remove those two screws, take out this, and then remove these two screws again. Oh yeah, by the way, did I mention the black wire is ground, and the positive side from the battery box goes via the built-in switch inside the DC connector. So that means you can automatically just pull it in and out, and then it will switch to external power or battery power. So, but that means it is a positive center pin power supply here that you need. So be very, very careful about that. I don't really see any good diodes or anything like that in this area. This one is called D7, that one, but I don't know if this is has anything to do with that circuit. So I would be afraid. So I was able to take everything out. It's just full of pieces, little plastic pieces of anyway. So yeah, we had to remove this screw here and desolder this, desolder the A input. And yeah, what else can I say? Yeah, the display here, that is definitely looking like moisture got into the contacts all over the place. And we got two big driver ICs underneath here as well. So I should probably just clean everything and see if I can fix that. We are interfacing to the LCD via all those signals right here. It's probably just 4-bit and some clock latch select stuff. I don't have a schematic for this unit. Oh yeah, by the way, see the solder mask, how it's blobbed up with solder from underneath from the soldering process. If you ever owned a ZX Spectrum, you will know that this is exactly how they look. And that is because they definitely went through the same factory, the same yeah, the same everything. And that is why it's looking like that. There's a funny little detail here. That one is a fuse that is built into the circuit board. So when it breaks, you can repair it. That's quite cute. And why would you have this on the bottom side? That is, of course, if this breaks, this will be sent in for service or something. You don't want people to know about this little trick. There's, of course, there's a reason why, and that could be tantalum shorted or something like that. But I think all this electronics here kind of works. I think I only need to focus on the display part of it. So now the LCD is out, and this is definitely in this area where I have some problems. And of course, you can see a lot of places in this unit. We had a lot of humidity, corrosion problems. Here, this is definitely also corrosion. All those, you can see what I mean, all those spots. And you can see the display is from 1980. The corrosion goes all the way through. That is really bad. But I think there's also some problems with some of the contacts here. So I'll try and get this off. And what, I don't know if I'm able to video that, but the metal clip here connects to a little thin piece of, there's actually a thin transparent layer of metal on this glass. Why can't we just have a focus that works? And yes, here in the shine, I don't know if you can see. Yeah, but I will try and take this off, try and clean everything here and put it back together. I was very careful to take a little bit of note about this spot here and the missing dots in this area. And this is where the top left is, the missing pin. Also, this is the very classic IC M7224. They're also called ICL, they're Maxim, they're from many different brands, and they are LED or LCD drivers, including counters. And they can drive 4 or 8. Yeah, you need 2 of them to drive 8. And all this you could easily find in the data sheet of this chip. And yeah, those chips are from 1979. So that is why you don't need that many signals. All the counting is done in those two chips. And if you take a little note here on one of the chips, you can see there's some green corrosion down here. So I'll try and see if I can take these out and clean everything here as well. Maybe I need to put in some sockets or something like that, but I'll definitely try and get the IC out. And then we can probably see what is going on. I'm always really, really careful about that. Look at the corroded pins. Well, that is really, really bad. This we need to have nice and clean, good contacts. So after a little bit of desoldering and cleaning up, I took out the two corroded sockets and they really look super, super bad. And I cleaned the board really nice. So I'm really thinking about just soldering in the chips. See, I cleaned the pins as well, because I really think the chips, they work. It's all about connection. So I think I'm gonna just solder them in. See, I remove all the nasty corrosion. It took quite a long time to do all this, mounting the chips directly in here, cleaning everything up. I've added varnish around everything here so I don't have any leaks. And the display, now I think it's much easier to see the contacts. I have of course cleaned this a little bit. You should be a little bit careful not to rub away the contacts, but I called an expert, Peter, and he said it's actually not that easy to do. You could even clean this with IPA and such, and they will still be quite fine, but I'm a little bit skeptical anyway. But I tried to clean them a little bit. And then I took all these contacts and I pressed them a little bit down. And then I also cleaned them with my glass hair brush all the way from the inside this angle. So when I put these back, I hope I'm not going to hit exactly the same location where there is a missing contact. I also cleaned these. So I think I am so much ready to try and assemble all this, and hopefully it's fixed. If it's not, I mean, sorry, it's gonna go to the bin then. Winner, winner, chicken dinner. All this soldering and cleaning and fixing and doing and God knows what, it really paid off. I now got a really nice display that's running. Look at that. I am so lucky. I don't know if it's just luck, but I'm just really happy. That was a few hours, I definitely must say. So now I am restoring all the broken plastic pieces with epoxy and all that. But there's this tab, and this tab is holding the angle. So this is the bottom piece, and the handle bends into this little stopper tab. And it's about 5 millimeters diameter, right? And in the other end, it was also broken. So what I did, I drilled a hole at the exact location of 5 millimeters, and I found a transistor, a plastic transistor, the right length, the right diameter. Okay, it has a little tab here. Oops, it has a little tab here on the side, but cut away the pins. But now this will stick through, and I can glue this with epoxy, and I think that will work quite fine. Funny. So I'm done with all the mechanical fixes and the reassembly of everything. And I'm still super happy about the fixes to my display. I was able to clean up everything here super nice. And I added a diode to the input here, because the power supply circuit, I don't really see a protection diode or anything in that area. So I think you could potentially break this if the input is reversed. I'm so sorry about that. What else can I say about this unit? Yeah, the power supply connector, the original one. I just went through some of my boxes with these DC connectors, and I find none that matches this type of connector. And I think it's because the center pin is quite large compared to the diameter of this. Yeah, it's just not an easy to find type. I just wanted to show you real quickly the schematic of the time base. So the crystal is a 4 megahertz crystal, and then it's dividing down to 1 megahertz. Here is the low frequency amplifier. And also note the supply voltage is 5.5 volts. So they cranked up the voltage range. And here is the high frequency amplifier and prescaler. So as you see, I need to perform a little bit of calibration. I just powered it up. And since there isn't anything that gets warm in here, there is no warm up or something like that, you could expect this to drift. That's just not the case. So I'll try and see if I can trim this to be more accurate. I just don't expect it to be that easy. Okay, I take it back. That was super easy. It turns out that the trimmer for frequency adjustment is made with a very, very healthy adjustment gain, so to speak. So when you turn this, it is just doing exactly what you want. So it's super nice and easy, and you get a very good and accurate readout. And remember, this is 1 hertz, by the way, just to mention how nice and stable it is at the moment. So anyway, I will just pack this up and say thank you very much for watching. Hope to see you soon again. Bye bye.